Good morning, good afternoon, good evening, wherever you are. I hope you're doing well. We are about to discuss rotations within the coordinate plane. Now, as you think about rotations, just something to keep in mind. Obviously, you know what it means to rotate. Okay, it means to move, and usually when we talk about rotations within the coordinate plane, it's around a certain point. Okay. Now my mind goes to the merry-go-round on the playground. Okay. The other day we were at the Bluffton Park, and my daughter was like, "Where's the merry-go-round?" She was so frustrated. They had removed it, so I don't know what's going on with it. They might be fixing it, but she was definitely not very happy because she likes to rotate around that certain point, and we call that the merry-go-round. Okay. So there's another concept that I want to make sure that we understand when we talk about rotations, and that's this. What direction are we rotating? Okay. Are we rotating forward, clockwise, which obviously clockwise, if you think of the clock, I'm sure you all know this, but the clock hands go this way, so therefore clockwise would go that way. And maybe I should make a note of that. Clockwise. Versus, what's the opposite direction of clockwise? Well, obviously that would be the opposite direction. We call that counter clockwise. Okay? And so make sure that you know which direction you're moving, you're shifting the object. Now, I'll be honest, even pre-algebra, geometry, even algebra 2, pre-calculus, we only move things really within 4 different directions, okay? And so as you look up here within the graph, you've already got 3 triangles that have been rotated from the first triangle, which would be this one. This would be the pre-image, move to the image, and then this becomes the pre-image, which moves to this image, and then this becomes the pre-image, move to this image. But it's all with respects to this one. And they're rotating it around the origin right there. And so as we look here, it's important that you understand the concept, which points match up with which points. You notice here that this side is the longest side along this triangle B. Okay, so as you look over here, this side's the longest side. Is it the same length? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It is. And as we continue to rotate, notice this point right here, this point here, becomes here, here, and here. Actually, I was thinking about this the other day, and maybe I should have tested this before I put it actually on a video, but I was like, I wonder if it's always the same distance from the point of rotation. So if I were to bring this out, do you think that this is going to rotate and be the same distance? Huh? Well, you know, I mean, I guess if I increase the length here just a little bit to get it actually on the point that we're looking at, let's see here. Yeah, it looks like it's pretty close, you know, and that could be a grid issue on my coordinate plane, and so just something to think about. Another way to test this, remember we talked about using the Pythagorean theorem, over 1, up 1, 2, 3. Over 1, 2, 3, up 1. So this length here would have to be the same as this length here. What about this one? Over 1, 1, 2, 3. So the right triangles here, here, and here are all the same. And let's try this one over 1, 2, 3, down 1. Look at that. Okay. So those distances are all the same, even though my compass didn't show it. And maybe my compass might not be set right, or you know how the grid can sometimes be off by a little bit. But according to the grid, there the dimensions are all the same. Therefore, they have to be the same distance from the point to which we are rotating. All right. Now, having covered that, what we want to do is this. You notice, if I go back to where we were talking about counterclockwise, okay, it's rotating this way. You notice if we go from B to B prime, we're moving counterclockwise in a counterclockwise manner, okay? So we're going against the way that the clock would go. Clockwise would obviously be this way, okay? And so just some things to think about. I think they're pretty much second nature. I think you guys probably have that understanding, but I want to make sure I verbalize them so that you have them. Now, if you look at your paper, down below, I'm going to make this a little smaller. Okay, down below here, you actually have an entire chart. And I'd like you to pause your computer real quickly here, and I'd like you to take a look at these figures here and how we rotate them. And what we're trying to do here is this. We're going from triangle B, which it lists all three of the points of the triangle, and we're rotating it 90 degrees. Now I would just go take this point and ask yourself, what are the ordered pairs for that point within the other three triangles there? For example, I've already kind of covered that this point is this one, it's this one, and it's this one within the three other triangles. So you can actually go ahead and record, let me see here, you can record, that's -3, 1 for the 90 degree turn, and I'm going to make sure that we understand that this is 90 degrees counterclockwise, because we're going to talk about what it would be if it was clockwise, counterclockwise. Okay, the 180 degree turn, which would be in the opposite quadrant, so we're in quadrant 1, this is quadrant 3 over here, is -3, -1. Okay, and then the last one, the 270 degree rotation, right over here, is 3, -1. Okay, so take a couple minutes here and see if you can fill out the other two rows there. Actually, you know what? Let me make one other comment before you go ahead and do that. We said this was a 90 degree turn counterclockwise, so against the clock. This is a 180 degree turn counterclockwise, but it also would be a 180 degree turn clockwise. And so I'm just going to make a little bit a note here that this would be the same. And maybe we should make another note up here. Let's see here, I spelled that wrong. Clockwise, nice job, versus counter clockwise. Okay, those will always be the same, 180 degrees. Either way, you end up at the same spot. And then 270 degrees, again, this would be clockwise. Or counterclockwise. Boy, I botched that. Counterclockwise. Okay, again, we start here, 90, 180, 270. It's 3 quadrants away from the original quadrant. 3 sets of 90 is 270. Okay? So take a couple minutes here, fill in the other rows for me, and then we will discuss, pause your computer, we'll discuss what those other measurements should be. Okay, now we're back. To fill in the rest of the information, hopefully you already have this. -3, +8. We have -8, -3. We have 3, -8. And we have -7, 5. And we have -5, -7, and then 7, -5. Okay? And so again, those are, just following the pattern all the way around. That's what we have there. Now, from that point, I want to go ahead and make up the rules. Now, we've done this last couple of days when we did the translations and the reflections. We've done it with both. And so as we look at the rule for this one, I'm going to move this down a bit. All right, so went ahead and re-recorded those there so we could see them, but I wanted to take a look at the rules here. So number 2 says this: how does a 90 degree rotation counterclockwise transform each coordinate of triangle B? Now, to form the rule here, I'm going to go ahead and do this. X comma Y. What does it become after that counterclockwise rotation? Well, hopefully, if you can fill that in, go ahead and do that right now. But as you look here, 1, 1, 8, 8, 5, 5. So a 90 degree rotation, the X goes to the Y position, and it stays the same. Now the Y goes to the X position, but it becomes the negative. Okay? So this is going to be -Y. Okay? And that's a 90 degree rotation counterclockwise. Now, if you think about this, there's another way we could call this same rotation. Instead of going 90 degree rotation counterclockwise, we could go, well, if I go 3 quadrant movements in the opposite direction of the original triangle B. Okay, so look at B real quickly with me. And I go from B to quadrant 4 to quadrant 3 to quadrant 2, that'd be the same location. 3 quadrant shifts, that'd be 3 90-degree shifts, is 270 degrees. So this also could be called a 270-degree rotation clockwise. Okay, you're no longer going counterclockwise, but clockwise. So understand that we can end up in the same spot by going 2 different directions. I hope that made sense. Now, for the 180-degree rotation, remember what I set up above, the 180-degree turn, clockwise or counterclockwise, we end up in the exact same location. And so if we start with x comma y, so we're starting with these points here and comparing them to these points over here. What does that give us? Well, we have 1 and we have -1. We have 8 and we have -8. 5 and -7. So whatever the x value is, the negative of that x value will give us the x value of a 180-degree turn. So it's the complete opposite, if that's how you would like to look at it. We have 3, -3, 3, -3, 7, -7. This will be the negative y value. It's the complete opposite, which should make sense to you. If we're doing a 180-degree rotation, it's going to be on the complete opposite side of the graph. Number 4, 270-degree rotation counterclockwise. If we start with x comma y, this time we're comparing this column to this column over here. What we see here is this. We have a 3 and a 3, a 3 and a 3, and a 7 and a 7. So the y switches with the x. Okay, it now becomes the x coordinate. I have 1 and -1, 8 and -8, 5 and -5. So the x value just becomes the negative. Okay, and that would be a 270-degree rotation counterclockwise. Now, one thing that you want to think about here is this. What if I were to do this rotation clockwise, how far would I have to spin to get in that same spot? Well, if we go back to a 90-degree counterclockwise rotation, that's equal to 270-degree clockwise rotation. Wouldn't it make sense that if we have a 270-degree counterclockwise rotation, that would be the same as a 90-degree clockwise rotation? Okay? Has a lot of rotations and a lot of clockwises, but that's what I want you to make sure you understand. If we're going from B and we're going to do 270, we're going to go quadrant 2, quadrant 3, then quadrant 4. Well, it's the same thing as going from B to quadrant 4, so that's just a 90-degree turn. Okay? Now, if you would, I'd like you to go ahead and just pause your computer and try to figure out what these values will be when we have a 90-degree clockwise turn. Okay, 180-degree clockwise turn and 270-degree clockwise turn. So again, pause your computer and see if you can figure out those values for me. All right, now, I'm going to be honest. I think the 180 is probably the easiest because it's the complete opposite of what we have here. Okay, same position but complete opposite. You see that? Same position, x is in the same position, y is going to be the same position, but they're just the opposite. So here, this will be -2, -3. Here, the opposite of -2 is 2. The opposite of 4 is -4. And if we're going from -1, -2, the opposite is going to be 1, 2. Okay, so that one was pretty easy, just the opposite but keeping the same location. Okay. Now, for the 90-degree rotation, we're back up here. We're going to change the x and y value. We're going to switch them and make the now x value negative. So if I switch them, 3, 2, and I'm going to make this x value negative. If I switch them, it's going to be 4, -2, but I'm going to make the x value negative. Okay? I'm going to switch them, -2, -1, but I'm going to make the x value negative, which changes it to +2. And that's what we have there for those 3. Okay? And then applying the rule for 270-degree rotation, we're going to switch them, but we're going to make this second value, the y value, negative. So if I switch them, I get 3, 2, but the y value becomes negative. Switch them, I get 4, -2, but that y value becomes negative, which 2 negatives make a positive, which is why we have a plus sign there. I'm going to switch them. So -2, -1. My y value becomes positive because a double negative becomes positive, and that's what you should have there. Okay? And so I hope that made sense to you guys. Now you can actually flip over your worksheet to the other side. And actually, let's start with numbers 5, 6, and 7, just so that you can understand what's going on there with those. So I'm going to clear this, and let's go over to numbers 5, 6, and 7. I'm going to make this bigger so you can see it better. There we go. Okay. And I'm just going to go ahead and put it down here so we can see a nice big graph. Okay. So in number 5 it says this: graph the image of triangle ABC with vertices 4, 5, B at 5, 2, and C at 1, 1 after 180 degree clockwise rotation about the origin. So go ahead and graph those 3 points for me. Okay, now that's the original, that's the pre-image. Where does the new image lie if we rotate 180 degrees about the origin? Well, let's get some frame of reference here as we move this. Obviously point C is going to be the closest to the origin, down in here somewhere. Point B, if I were to take this line right here and rotate it, just, I didn't want to do that. Sorry there, guys. Okay, if I were to rotate it, bringing it on down all the way over here, B would line up somewhere over here, A would line up somewhere over here. So it's important that I can see C, A, B, somewhere in that general vicinity there. You got to think that this orientation continues all the way around, okay? So with that being said, let's see here. 180 degrees means that everything's in the opposite. So if we have 1, 1, this is going to be -1 and -1, okay? So that would be C prime, the new image. B, we said was 5, 2. And so from there, both are opposite, -5, 1, 2, 3, 4, 5, -2, 1, 2. B prime, and then A, which is going to be at 4, 5. Both are in the opposite, -1, 2, 3, 4, 1, 2, 3, 4, 5. There is our new figure. Okay. So from there, did it meet our standards? C is the closest, B is in front of A, that's good, and that's the new figure that we would need. Okay. See if you can do the next one for me. Okay. See if you can figure out what that would look like if it was a 180 degree rotation clockwise. Actually, you know what? I want to pause on that. As I'm thinking about this, I'd like to see if you guys could do the 90 degree rotation counterclockwise and the 90 degree rotation clockwise. Okay? Now, what I need you to think of is this. Remember when we go 90 degrees, a flip has to be made. So remember the y becomes the x. The question that you'd have to remember is, which one is negative? Okay? Remember, which one is negative? Well, if you're going 90 degrees counterclockwise, meaning you're moving into this quadrant here, the first value has to be negative, because along here, if I was to count negative and a positive, the first value has to be negative. Okay? So I think that's an easy way to remember that. If that helps you out, do that. And if well, we'll talk about the other one in a bit. So again, this is a 90-degree counterclockwise. Okay. So if I do that, I switch those two and make the first one negative. So it'll be -1, +1. There's your C double prime. We'll say this is the second rotation. From there, A, switch them. So we have 5, 4. Now it's -5, 4. So -5, 1, 2, 3, 4, 5, 4, 1, 2, 3, 4. So the A value right there. Okay. And then from there, B value 5, 2. Now we switch them. So we have 2, 5, but it's -2. So -2, 1, 2, 3, 4, 5. B double prime. Okay. So let's see here. Does this meet our understanding of the rotation? Okay. And so as we look here, let's see. C still close to the origin. I like that. If I was to rotate this way, A leads B. So A has to be in front, B in back. It's got to be the same, okay? 90-degree counterclockwise. Now, if I want to go down in here from this original one, this would be 90 degrees clockwise. Okay, again, or you could say 270 degrees counterclockwise. Either way, it's the same thing. Now, remember, if we're going a 90-degree rotation or a 270-degree rotation, we're going to switch those two. And the question is, which one then becomes negative? Well, if I'm going to be in the fourth quadrant, this is going to be a positive, and it's going to have to be a negative. So this second value has to be the negative, okay? So as we do this, I switch them. 1, 1 still is 1, 1. But this time, my second value is negative, so it's going to be 1, -1. C triple prime, okay? I have 4, 5, switch them, that's 5, 4, but my second value is negative. So 5, 1, 2, 3, 4, 5, -4, 1, 2, 3, 4. That would be A, triple prime, okay? And then the last one, if I'm looking at this one, switch them, 2, 5, make the second value negative, so it'll be 2, -5, 1, 2, 1, 2, 3, 4, 5. B triple prime, okay? All right, so from there, does this meet our understanding of the rotation? Well, C still remains closest to the origin, that's good. And if I rotate this way, B is going to lead A, and that's good. Now, something else to think about, it might be hard to tell. Can you tell whether all the triangles are congruent or not? And if I look here, the dimensions, to find the length of AB, I'm going to rise 3 and run 1. AB, 1, 1, 2, 3. Still the same right triangle, 1 by 3 right triangle. 1, 1, 2, 3. Same right triangle, 1, 1, 2, 3. Same right triangle. So those lengths are all the same. If I go BC, 1, 1, 2, 3, 4. 1, 2, 3, 4, 1. 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. Well, the dimensions are the same to make the right triangle, and if 2 of the 3 sides are the same, we know that the third side is going to be congruent as well, as long as the angle's congruent, and I can prove that. But we can always double check. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. So 4 by 3 right triangle gives us the same hypotenuse length. So I hope that made sense to you, and I hope that that helped you out. Looking at number 6, let's do that one real quickly here. As you look at number 6, if I were to go and graph that, you have L, which is at -3, 2. 1, 2, 3, and then a positive 2. That's L. M is at 2, 1. 1, 2, 1. and then n is at 0, -2. Okay? Now, if you go ahead and graph that, you've got this triangle here. I realize it's not very big for your graph there. I apologize about that. I probably should have made it bigger. But what's different from this triangle than the ones that we've looked at so far previously? And what's different is that this one actually touches all 4 quadrants. So far, we've only had to deal with ones that are in a single quadrant, okay? Now, we want to do 180 degree clockwise. Again, 180 clockwise, counterclockwise, does not matter. And so I'm just going to take and make the opposite of each one. So this one was at -3, 2. So the opposite of that would be 3, -2. 1, 2, 3, -2. There's L prime. Okay. This is at 2, 1. So I'm going to go, let's see here, -2, -1. -2, -1. Okay. There's M prime. And then for 0, it's 0, -2, so it's going to be 0, +2. Okay. And if you go ahead and graph those, we'll talk about whether this makes sense rotationally in just a second. Okay. So does this make sense rotationally? If I were to go ahead and take this figure here and rotate it 180 degrees clockwise. Well, if I do that, this is going to end up second quadrant here, fourth quadrant here, directly opposite. That's good. First quadrant, third quadrant, that's good. 2 below on the y-axis, 2 above on the y-axis. So, and that's good. If we think about it rotationally now, if we look at this point with respects to this point, is 0 following L? Well, as we go around, 0 is still following L. Does M follow O? I said 0, O. Does M follow O? Well, as O goes up there, M follows it. It's the next one closest to it. So hopefully, again, without seeing me show that rotation, I hope I described that well enough. Take a moment, see if you can do the last one your own, number 7. Give yourself a moment to see if you can do those, and then you can double check with the subs notes to make sure you've got that right. Now, and so you want to pause your computer here to go ahead and do that, because I'm going to move on and we're going to talk about rotational symmetry here. Now, the other day, we talked about symmetry, which means the same on both sides. When we talk about rotational symmetry, what we're talking about is how many times can we rotate the figure that it will actually, kind of like a key, go right on top of itself. When I think of a key that goes into a lock and it rotates, obviously it has to go into a certain position to release the lock or to lock the door. And so think of the star right here. As it rotates, how many times will it map over itself? Go over itself the same amount of times. So as you look here, here's what we're going to do. If I was to take this point and rotate it to that point right there, would this point be here? Would this point be here? Would this point be here? And would this point be here? Yes, it would. So that would be one rotation. If I take, now this point is here. If I take that point and rotate it over here, would, now that this point's here, would this point be here? Would this point be here? Would this point be here? Yes, it would. Okay, so that's 2 rotations. You're probably starting to catch on what's going on here. If I rotate this point over here, if I were to rotate that point over there, would this point be here? That would be that one. Would this point be here? Would this point be here? And would this point be up here? Yes, it would. Okay? And so as we continue to do this, I think you got the handle of it. There would be 5 different rotations there that would map directly over itself. Okay? So just keep that in mind as we work on this. How many rotations would we have in number 2? Well, 2, if this one goes here, then it would map on itself. And then this one goes here, that would map onto itself. It goes here, goes here. So there's 4 different rotations there that would occur and would still map onto itself. Okay? A regular octagon or a stop sign, how many times could it map onto itself? Well, this side could rotate here and all the other sides will fall in place. This side could rotate here, all the other sides will fall in place. We can do that over and over again until we get back to the beginning. There's 8 different possibilities there. 8 rotations that could occur and it would still be mapping on itself. Okay, the last one, okay, if I took this point here and rotated it over till it was here, it would map onto itself. But then I have to go back to the beginning, and so there are actually 2 rotations there for number 4, and it would map onto itself. Okay? So, this is actually the last video that you have to watch this week. What I have planned for the rest of the week, Tuesday, there's no homework tonight. Tuesday, you're going to do some problems for me. Wednesday, you're going to correct your quizzes you took the other day. Thursday, you've got a section review. And then Friday, you have a chapter review. So that's kind of the layout of what's going on. I hope that made sense to you. Your learning this week is on you. You're expected to have everything turned in by the end of the week. If you don't, then you'll have to turn it in on Monday to me, but it is expected to be in to me by first thing Monday. Okay? I hope you're doing well, and I look forward to seeing you all next Monday. Goodbye.